PART, right? And you guys know it goes in order clockwise or counterclockwise. So PAR's got to be somewhere over in this region right here, PART. A property that might help me out of a parallelogram right now. Property. Okay, congruent. Do I want to use distance formula again? No, but I might want to use parallel. So wherever you put R, RT has to be parallel to AP, which means what about our slopes? They got to be the same slope. So can anyone go ahead and find me what the slope of PA is? Because whatever the slope of PA is, it's got to match the slope of RT, wherever I put R. So up and over how many? Or you can use change in Y over change in X. Slope of PA. Up and over how many? Anybody have it so far? Up and over? How many are you going up? 11 over 3, and this is a negative slope. So how do you suggest, knowing that the slope's got to be 11 over 3, how I can find where R is now? Well, I don't want to do negative reciprocal because those will be perpendicular. I want to keep it 11 over 3. From where? Now start from T now and go how many, Will? Over 3, up 11, or up 11 over 3, whatever order you want to go in. Okay, so now starting from T, because remember, RT's got to have a slope of negative 11 over 3. So going from T, Will said go to the left 3, up 11, or up 11 to the left 3 in any order. So go right ahead, and then you let me know where you end up, where point R should be. New point R? 2, 2, 9. There it is, 2, 9. Finally, and I'm not going to do this one with you, I'll let you do it on your own time. Prove to me now that that is actually a parallelogram. What I want to do with you guys for reviewing is all the different ways you could do it. And then you guys pick which one's the best for you. So how can I prove a quadrilat, that bad boy is a parallelogram? So you're doing opposite sides parallel by doing that, right, Will? Yeah. So opposite sides parallel, and you would need 4 slopes. Again, I'm just going over the different ways you could do this here. What are the other ways you can make it into a parallelogram? Opposite sides congruent, yep. That would be 4 distances if you decide to do it that way. Anybody remember the special case that makes it into a parallelogram? One pair of opposite sides congruent and parallel. And that would be 2 slopes and 2 distances. And then there is actually one more way you could do it. And I want to go over this way because I don't know, they may bring it up next Tuesday. Diagonals bisect each other. Anybody remember in what formula we use to show diagonals bisect each other? Midpoint, yep. What about the midpoint? You would use 2 midpoint formulas. If the midpoints are the same, the diagonals bisect each other. All right, if the midpoints are the same, the diagonals bisect each other. Okay, so I'll, on your own time, you can do another proof that says it's a parallelogram depending on what way you want to do. But just remember this one because this may come up in multiple choice. Diagonals bisect each other if they share the same midpoint. All right. Okay, on Friday, I said I was going to open it up to you guys. anything, fair game, specific exam, specific question, topics, whatever. Constructions are on the board. Geez, don't forget to look at those too. Constructions, I got a whole folder full of them in there. Whole bunch of videos you can watch. And if you're wondering what constructions I need to know, if you have the cold hard fact sheet, I believe the last page is a whole slew of constructions that are needed. All right, so just check that out. Okay, here we go. Last page. Let me just. Yep, the very last page are all different ones. All right. Okay, Will, Cam, you're on deck. June 2010. Is this the Freddo one?
Yeah.
The one they had to do last year and just went nuts with? Okay, here we go. Unfortunately, unfortunately for the kids last year, they had to struggle through this problem. Some of them got them. And it is a 6-point question, so there is some partial credit, so please don't leave it blank. But luckily for you guys this year, this type of question won't be on part 4. Okay, because there's only a proof. One question on part 4, and it's going to be a proof. But this could show up somewhere in the part 3, maybe a scaled down version, but it's still good to go over it because there's a lot of different things going on. All right, good old Freda. I think that name still haunts some of the kids I had last year. Detects an airplane, yep, landing over location. She sees an airplane. Okay, first thing, angle of elevation. Angle of elevation tells me I am dealing with a right triangle. Anybody remember where the angle of elevation was located? Inside, ground up. Inside, ground up. So inside, ground up, 15 degrees. Anybody remember what, just while I'm here? That angle right there. That is depression on the outside. Okay, depression on the outside. I'm just going through everything here. And notes, it's altitude, so it's distance. Altitude, what do we think about when we think of altitude? A line that is perpendicular, yeah. And there it is right there, the line that's perpendicular. Altitude, 6,250 feet. There were a couple part 1s that they accepted multiple answers for, but that's about it. Not any of the free response. Okay, 1 minute later, she sees the plane at an angle of elevation of 52 degrees now. Okay, now she's at 52 degrees angle of elevation. Plane has traveled. So what I'm going to do is I'm going to make another line here to make another right triangle for 52 degrees. And this is not the only way to draw the diagram. I think this is just easier for me to explain to you guys. So she sees it at first at 15 degrees. 1 minute later, she's over here and sees it at 52 degrees. And we're looking for how far has the plane traveled to the nearest foot. So she was here at 15, now at 52 degrees angle of elevation. How far did it travel? That's what I need right there, is that distance. How far did it travel to go from 15 to 52? And really, the diagram is the hardest thing. Once you have the diagram set up, now we can go to town. Thoughts on finding that side?
Find the hypotenuse of the right triangle to the right.
Well, first of all, is this side a full side in a right triangle? Okay, so you can't use sine, cosine, tangent. Okay? There's something else I have shown you guys that you can use no matter what the triangle is. Law of sines. And this is a good problem to go over, Will, because law of sines is pretty darn powerful because it can be used in any type of triangle. Yes. Say that again. So what? Okay, there is a way to do it with SOHCAHTOA, yes, but go ahead. So you want to, okay, so let me just make sure I'm good to go here. You want to use the big right triangle, 15 degrees, 6250, and find this whole side, right? With 52, but you're going to find this side and subtract the 2. That's fine. Yes. Would we rather do it that way, or do you want me to use law of sines in case you need it? Okay, law of sines. Law of sines can only be done on one triangle only. And it cannot be done on this one right now. Anybody know why I can't use... Other than x, I don't have another side. Okay, other than x, I don't have another side. So what I'm going to do is I'm going to use law of sines on this smaller one first. Anybody know what side you can find right now using law of sines on my blue one that I've highlighted? The hypotenuse, yes. So let's go over law of sines again. This, again, can be used on any type of triangle you want. Give me a side you know. It's got to be all from the blue triangle. 6,250 over, what do I put opposite it? Oh. All values have to come from the same triangle. 6,250, what's the angle across? Okay, hold on, not correct. Sine of 52. Now give me another side. I don't want to, I'll call it, you guys said I could find the hypotenuse, so I'll call it y. And what's that across from? Sine of 90. Again, make sure your calculator later is in degree mode. Divided by sine of 52. We are not done with the problem, so I'm going to write out my full calculator display right now. 5663.209901. That's that side right there. Now, can I use law of sines on the yellow one? Absolutely. And of course, my calculator is in radian mode, because that's what happens when kids take them and clear the memory and they're in Algebra 1 and don't need radians and degrees. All right, let's try this again. I'm surprised no one jumped down my throat yet. There we go. How about this now? 7,931 point. There we go. All right, next law of sines. Give me a side in the triangle I'm working with now, which would be the yellow one. The one I just found. Plop. Over sine of 15. Any other sides in that triangle? The one I'm trying to find. Yeah, that's the solution, x. And now we got to do a little 180 minus, minus, minus to find the angle across. Yep. Where, here? Because this side is across from that angle in this triangle. What do you mean we didn't use it? Okay. Okay. That's fine. Because not everybody knows sine of 90 is 1. So that's why. All right. Still waiting for this angle here across from the side. $37. Should I just stop doing this problem if we're not going to work on it here? This angle here.
Wait, do you do 90 minus 52 or 180 minus 52? To get the
You tell me about these two angles.
It's complementary, right?
They're a linear pair. They form a straight line. Okay? Straight line's equal to 180. So I have 37, yes? Okay, so over sine of 37. And then I'm going to cross multiply. And then I'm going to divide by the sine of 15. And what's my rounding directions here? Nearest foot. $18,442 feet. Okay. Do we even do the next part, or are we going to keep going here? Determinant state the speed of the airplane to the nearest mile per hour. Okay, let's make this real easy. What's this answer in? Feet per what? After what? What did we just find? 18,442 feet after 1 minute. 18,442 feet after 1 minute. And we're trying to get it into what? Miles per. Okay, so now we have to figure out how many miles are in 18,442. That's on your reference sheet. At the top, there's a conversion that goes from miles to feet. $5,280 feet in 1 mile. So can we find out how many miles are going to be in 18,442? Anybody got a number? About 3 point, and I don't want to round anything yet because I'm going to divide these in a second. 3.49280,303, and I think that's the tougher one, the easier one. The tougher one's coming now. Yep.
Would you want to keep the whole entire decimal from the first part?
You could, yes, but because they asked you to round it already, you can keep on going with it through the entire problem. Good question, Justin. Yep. Here's the tough part. 1 minute is how many hours?
0.6.
It's a very small, correct? 1 minute is how many hours? What do you want to do with that 1 minute? Divide it by? Yep, divide it by 60. So 0.0166 all the way. Okay, we get it. Let's divide those two. And what's it say? To the nearest mile per hour. So to the nearest mile, what are we looking at? 200 and? I have 0.5 on mine. 0.568. 210 miles per hour.
You have to put the little squiggly thing.
No, not at all. Cam, you had a question?
Can we just
Or a
go over-
topic? Or go ahead.
I have a topic.
Go ahead.
Just go over the
Sure. It's probably better if I do an indirect proof altogether, huh? So let me. What's that? Correct, but that doesn't mean a darn thing next Tuesday. Okay, PDFs. Let's open up this packet. Okay, here you go. I don't know if anybody, I'll give you guys a second if you want to copy it down or not. Sorry about that, diagram's off a little bit. Those are only supposed to go to A, D, and C. It's not in any, I just got it from your Unit 5 packet back in the day. Okay, I'll talk as you guys are writing here. First thing, how do you know, other than me telling you and Cam asking for one, that this is going to be indirect next Tuesday? What's up, Luke? Calm down. Okay, if you are asked to prove something not happening, I have to do this indirectly. Yes, nice job. What? Oh, I'll talk about that in a second. So you got your given, and then what should probably be your next step after your given in an indirect? That's okay. Everyone remembers it's an assumption, but where do I get this assumption? What am I going to assume here? The opposite of the proof. Don't touch the givens. The opposite of the proof statement is true. So we're going to assume that BD bisects AC. And we can treat that now as a given and use it in our proof. And I think here's the toughest part. What are you trying to accomplish? Contradict a given. And in this case, which one was probably the easiest to contradict out of the two? Proving AB is not isosceles by proving it is isosceles. So that is our goal right now. You help me get ABC be isosceles. Okay? You have BD's an altitude. You have BD bisects AC. There's a lot going on here. Try to get me right now that ABC, the entire triangle, is isosceles. And this is also just a good proof in general. Anything you want to list out, facts you know now, 40 weeks in. Here we go. Mike, start us off. Oh, don't say a word. AD congruent to CD. The man is 100% correct. Anybody know why? Other than Mike. Emily. Definition of a bisector. Mike and Emily both use the assumption to their benefit. All right, we're getting it at isosceles sooner or later. I got one piece down. High heaven. Thank you. Angle. I'm not contradicting the proof statement. I'm going to contradict a given. I'll show you why at the end. Okay. So BDA and BDC are right angles. Having, why are they right angles? Okay, I like that. I don't know where that's going. And then everybody can just chime in here. Now you got to say, what about the right angles? They're congruent. Yep. Congruent to BDC. All right angles are congruent. Anybody want to add the old, just one last time, huh, for good old times? The old reflexive BD. All right, what do I know now? Two triangles are congruent by one of those 5 methods. Yeah. Triangle ADB. It's going to be a long one here. Love it, love it. And CDB, congruent. What method do you have there, kiddos? Side, angle, side. Why is it helpful to know the triangles are congruent? Either say one of two things now. The two sides are congruent, or you could go the angle A and angle C congruent. Either way will get you isosceles. What do we prefer? Of course, the sides. AB and AC congruent. Little thing we like to call CPCTC. Hey, what do I know about triangle ABC then? It's isosceles. That's a problem. Why is it isosceles? Two congruent sides imply an isosceles triangle. And Cam, here's your answer now. What led me to this? The fact that you assumed that that was true, right? And since that right there, that assumption led me to a false statement, that can't be true. The opposite has to be true. This is false. You agree? So if this is false, what's got to be true then? Well, no. This is we already determined that this is false, right? So the opposite, BD does not bisect, has to be true. That's why we choose the proof statement. BD does not bisect. What was it? Does not bisect AC. And anybody remember this little last statement? Assumption led to contradiction. If you want to tell me what steps, I always had you guys write that for me, but on the Regents, if it's on there, I don't think they're going to care, but you never know. Let's see, where are my contradictions? Step 2 and, I'm sorry, not step 2. One job. Step 1 and 9.
Why isn't it 2?
I said it was isosceles. Now I'm saying it's not isosceles. Okay, your contradiction's not your last statement and the assumption. Okay. Whew, that was fun. Thanks for asking that question. Anything else last minute here? I know it feels like there's so much stuff because there is, but anything else here before I just let you try some on your own? It's been real. It's been good. Hasn't been real good.